Hello everybody. So in the previous video, I got this great idea from a community member in the comments section that there could be an API to control the Game of Life 3D application functionalities. And this video is just about that. So on the left side of the screen, you can see this Game of Life control center, which is a HTML file to be shipped with the latest version of the application. And this has all kinds of controls which you would usually use via the UI of the application. But the great thing about this is that you can actually call each of these functionalities in any programming language or way you seem fit. This control center here is just an example application on how to use these features. And if you want to try this out, in the PC Steam version of the application, you can launch this API from the main menu, Advanced Controls. I have already enabled this API so that I could lay out these windows for this video. But if you click this button, this browser window will automatically open and you can start using the API functionalities. The control center here is also fully customizable. It's an HTML file you can modify in any way you want, and then you get your own personal touch on how you want to control these functions. But let's start to go through what we have available here. So first of all, we have the simulation size, and we can directly now here apply any size we want for our simulation, and the application immediately takes this new size we want to use. And of course, this is quite a bit faster than doing it via the UI. And also, as said, I can write any software application I want and drive these functionalities via that method. Then we have the simulation speed. As per usual, we can change this directly via the browser application. Then we can change the birth and survive rules for the simulation. We have the current rules visible here. So currently cells with 4 neighbors are getting born and surviving. We can clear any of these rules with the clear button or apply new ones by comma separating the values we want to use directly here. And the new values will be immediately taken into use by the application. Then we have this very interesting functionality, set state. And basically, we can use this to directly set all the cell activations in the simulation. So we can use this get state functionality to get the activation state of each cell in the simulation currently. And there are a bunch of these. So 1 meaning cell is alive and 0 meaning cell is dead. And at any point, we can resubmit this value to go back to the simulation state we had when we used this get state. We can use the clear functionality to kill all the cells in the simulation and then submit again to return to that previous state. We can also use the basic spawn functionality in the application, which is also usable from the bottom of the screen in the application UI. And the idea of the set state is that I can programmatically build any state of the simulation and then apply it via the set state endpoint in the application API. We will get back to this later on with direct examples. Then we have set rendering. We can turn off the rendering completely, which will speed up the simulation, and then we can of course turn it back on. We can pause the simulation at any given time and then start running it again, just like we can do from the UI. Then we have these spawn cell and kill cell functionalities, which we can use to directly apply a new alive cell in a coordinate of the simulation or kill any alive cell currently active in the simulation. These are not super useful to use by hand, but via the next example we are going to look at, this can be very handy to be used programmatically. So the very last functionality here is custom procedure. And I have written 3 examples on how we can programmatically set the simulation state of all of these cells. And let's run the first example to see how it can work. So this example is first going to kill off all the cells, and then it's going to use the spawn cell endpoint to instantiate all of these cells you can now see on the screen. And after doing that, it's going to let the simulation run its course in the normal manner. It has also set new rules for our simulation. As we can see, now cells with 9, 7, and 8 neighbors are both getting born and surviving in the function, in the application, I mean. And we can, at any state, run this example again to see how it works. And we can also look at the code ourselves. For example, via the developer tools of the browser, or we can directly open this file in our code editor to see what kind of code is underneath. But basically, we are just calling these endpoints which are documented here above in order to make these changes happen in the simulation. And in this example, we are basically instantiating cells on the very edge of the simulation and then leaving this cross gap in between. And doing this kind of thing by hand would, of course, be extremely slow and excruciating work, but programmatically, we can rapidly build any kind of shapes we want in the simulation. We can, of course, at any given time, again, use the get state feature to get the current simulation state and return to it at any given point we want. We have also another example, which is more of a flat pattern we are building here programmatically. And this is just to visualize that we can also build this kind of patterns very easily now programmatically, which would be basically impossible to do by hand. This seed builder we have in the UI is very handy, but building larger seeds is impossible and also very slow by hand. But programmatically, we can do this very rapidly. And when I see this flat example, the first thing which comes to mind is that people have already built computers, or rather simulations of computers in the Game of Life 2D. And now that we have this kind of powerful functionalities, it would be also possible to try this in the Game of Life 3D. And I think this would be an extremely enjoyable exercise, building memory circuits and bit adding functionalities and these kind of things in the Game of Life 3D. Maybe when I have time at some point, I will try this out myself, because it would be extremely interesting to see how it works. Then we have one final example, which is using this set state functionality directly, not initializing the cells one by one using this spawn cell functionality, but rather building up the simulation state and then initiating it all at once. And here we can see the set full state direct example, which is doing just that. And it's basically building these thick edges on each side of the simulation and then allowing the simulation to proceed from that state. And this is, of course, much faster if you don't kind of want to animate the change in, but just want to directly get into a state. This example is good for that. And in the developer tools, as said before, we can just quickly glimpse at the code. So this is the example code provided with the application itself. We have here the locally running API URL and all the functionalities which are used in this example, including the code examples where we are kind of setting up the state of each cell and calling these endpoints, which are defined now in the application. So I'm super excited about these new functionalities. These basically allow you to build any kinds of extensions for this Game of Life 3D application. And this being only the first version, I'm sure in the future we will also have more functionalities which can allow us to build more and more interesting features around the Game of Life 3D simulation. I hope you enjoyed this video. You can get this application on your own PC by following the links in the description. Thank you for watching and bye.